Okay, so this is task 4. This is balancing equations using a visual representation. So we're going to draw models to help us balance equations. This is our first balancing equations that we're going to do. On Monday, I will show you how to do it mathematically. And then you can move forward with doing it whichever way you like, unless I ask you for a specific way. So on this one, you do have to draw the pictures, okay? And then you can just use colored dots in Notability. That's totally fine. Or if you want to draw shapes, you can do that. But you do have to draw an actual model of the equation. So I'll do 1 and 2 with you. So let's look at, first thing I do when I'm drawing these is I find where the arrow is, and then I'll use that, I'll draw a line under there to separate the reactants from the products when I'm drawing them. Because that's our line that we want. We want both sides to match the numbers and types of atoms. So when we're drawing this, remember that in a chemical equation, the atoms are going to get rearranged, but we should still have the same number and types of atoms. Okay, they're just going to be connected differently. Okay, so the first thing we want to do is we have to have our skeleton equation here, so it's not balanced. We just want to draw what we have. So I'm going to go ahead and assign a color to each element. You can use whatever colors you want. So hydrogen and bromine, so that's hydrogen bromide. So you've got 1H and 1Br. Okay, there's no subscripts, so it's a 1 and 1. For oxygen, it's a diatomic, so it's O2. Oops. And so that there's 2 of them together. Remember, it's an element molecule. That's what a diatomic means. Use your Hofbrinkel to help you remember that those 7 are diatomic. And then let's do the product side. Bromine is one of those diatomics. So it's Br2 on the product side. And then water, H2O. So we've got 1 oxygen. And we've got 2 hydrogens. So then we want to look, and we're going to see I've got 2 bromine here, only 1 bromine there. I've only got 1 hydrogen here, 2 hydrogen there. I've got 2 oxygen, 1 oxygen. So you can start wherever you want to start. But I like to use like the little lasso tool that used to be the scissors, and you can just use that to copy and paste more molecules or atoms as you need them. So I need more hydrogen, so I'm going to start here. So I'm going to copy and paste. Okay, so my hydrogen is good. My bromine is good. Okay, if I look here, I've got 2 hydrogen, 2 hydrogen, 2 bromine, 2 bromine. But look at oxygen. Oxygen's not happy. So I need more oxygen on the right side. So I can't just draw another oxygen because I don't have oxygen by itself on the product side. I have to draw a whole other molecule that involves oxygen. So I need a whole other water molecule. And if you'll notice, that's going to throw off my hydrogens that I just fixed. Okay, that's okay. So I need 2 more hydrogen. So I'm going to need 2 more of these guys. So just copy and paste. Okay, so now you've got 4 of those. Let's double check here for the hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. Okay, hydrogen is good. Oxygen, 1, 2. 1, 2. Everybody's good. Bromine, 1, 2, 3, 4. 1, 2. So I need another one of these. So just copy and paste. Okay. So that's what we got to do. So now if we check everything, everything is balanced. So what we're going to do now is we're going to fill in our our coefficients. So to fill in the coefficients, look at how many molecules or how many atoms you drew. So in this case, we're going to look at, we have 4 molecules. So 4 is going to go in the first one. Okay, for oxygen, for O2, yeah, there's 2 atoms, but they're connected. So it's 1 molecule of O2. And usually we don't write ones as a coefficient. You can leave that blank. But if there is a blank there and you're the kind of person that needs to have something in the blank, you can put a 1. But when you go to actually translate chemical equations, we won't write ones for coefficients. Okay. Bromine, there are 2 molecules of bromine. And then water, there are 2 water molecules. So 4, 1, 2, 2 is your are your coefficients, or 4 blank 2, 2. Okay. Moving on to number 2. So we've got aluminum, oxygen as our 2 elements involved here. I'm going to draw my line under the arrow. Pick some colors. Let's keep red for oxygen since we were just using it. Pick a different color. Let's do blue for aluminum. You can use whatever colors you want. So aluminum, there's no subscripts, so we just need to draw a blue dot for aluminum. Aluminum is just an atom because there are no subscripts, so it's not a molecule. So for all of the aluminum atoms you draw, you're going to just draw separate circles. Oxygen is a molecule again, and you could just copy and paste that from the previous equation. That would be a good shortcut, but I just went ahead and redrew it. And then aluminum oxide is Al2O3, because remember that aluminum is +3, oxygen's -2, crisscross. That's how you got the subscripts, Al2O3. So there's 2 aluminums. So let's just draw 2 blue dots touching, and then 3 red dots touching. Right now, I don't care how they're connected, just that you have them connected. Okay? So, nothing is balanced in this one. Aluminum's not balanced, oxygen isn't balanced. So, let's look at the oxygen. I've got 2 on this side and 3 on this side. So, one way that we can look at that is, what can we get them to that would be the same? And we could get them both to 6 that would be the same. That would be the smallest number that we could go to that would be the same. So I would need, oops, my lasso. I need more of these. I need 6 total atoms, so that means I need 3 molecules. And then I'm going to need another one of these to give me 6 total atoms of oxygen. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 and 6 oxygens. That's great. Now let's fix aluminum. So we've got 1, 2, 3, 4 aluminums. Over here I just have 1. So we are going to add 3 more aluminum dots. I'm just going to draw those. And remember I said it's not a molecule because there's no subscripts, so all of those should be individual atoms. One tip for balancing these is if you have an element that is by itself like this, always do that one last. Okay? Always do that one last. It will save your sanity a little bit. So that's just a little tip I have. So for this one, our coefficients are going to be 4, 3, and 2. 4, 3, and 2. I did want to mention something about number 3 real quick, and that was this symbol right here. Hopefully you remember from the notes when there's a little triangle over the arrow that means the equation or the reaction is being heated. So it doesn't really tell us anything about the balancing part. It tells us more about like a physical representation, like what is actually happening in the reaction, and it's being heated. So that was just a little thing from the notes that popped up. Okay, so go ahead and finish 3, 4, and 5, and you can check your answers with the key in class. Let me know if you have any questions.